Hello everyone, welcome back to Exam Tomorrow series, Lecture 2, Differential Equations. So in this video, our topic of discussion is going to be non-exact differential equation, how to solve those kind of differential equation by finding the integrating factors and the rules of the integrating factors. So at very first, let us understand what is a non-exact differential equation. So suppose we have a differential equation of first order and first degree. And we already know that such a differential equation can be written in this format, m dx plus n dy equals 0. Now this differential equation is going to be non-exact if m partially derivative with respect to y and n partially derivative with respect to x, if these two outcomes are not equal, then such a differential equation is called non-exact differential equation. If they are equal, then that's exact, and that topic we have discussed in lecture 1. Okay, so now how to approach these kind of differential equations. So this is the entire flow chart that is going to follow. So first of all, I have a differential equation and let's suppose it is not exact. That means the two partials are not same. So the process is going to be, we have to find out integrating factors. Okay, corresponding to a differential equation, there is going to be an integrating factor. Once we find the integrating factor, we need to multiply it on both sides. So you can understand that I am multiplying the integrating factor on both sides in this differential equation. So the right hand side remains 0 after the multiplication. The left hand side changes. Let's say m has changed to p and n has changed to q after the multiplication. Now this differential equation becomes exact. Okay, so this is the work of the integrating factor. The multiplication with the integrating factor makes it exact. The moment it becomes exact, now we can solve this just like before in our previous lecture. Okay, now the question is how to find out the integrating factor. So there are basically 5 rules which we are going to do. There are going to be 5 rules that we're going to discuss today and then solve problems from each of these rules of finding integrating factors and then finally solving the differential equation. So without wasting any time, let's start rule number 1. Okay, so suppose I have the differential equation which is m dx plus n dy equals 0. So at first we don't know whether it is exact or non-exact. So at first we are always going to find out del m del y and del n del x, right? If by chance they become equal, that means they're exact. If it is exact, we already know how to solve them. Now let us suppose they are not equal. So now I have these two values, right? I have these two values. So what I'm going to do, I'm going to just subtract them, del m del y minus del n del x, okay? And then divide it by n, okay? Divide it by n. So an easy way to remember this is I am partially differentiating n with respect to x. So if I am dividing by n, the function also has to be a function of x completely. No term of y should be left behind after the division. Okay. So this quantity divided by n, if it gives us a function of x only and no y is present, then the rule states that the integrating factor is going to be e to the power integration of this particular function dx. Okay, e to the power integration of the particular x function that we have got, right? So I hope this idea is clear. So now let's do a particular problem. Let's say I have this differential equation. So you can understand this is my m and this is my n. So the very first thing that we're going to do, we're going to find out del m del y. So that means partial derivative of x square minus y square with respect to y, and that is going to give me minus 2y. Okay, then del n del x. So that's del x of 2xy, and that's going to give me 2y. So you can see both these quantities are not same. There's a minus sign here, there's no minus sign here. So they are not equal. So that means I have del m del y not equals del n del x. So now I'll take the subtraction of these two quantities. So I'm going to take del m del y minus del n del x. And if I do the subtraction, del m del y minus del n del x, you can see if I subtract this from this, so I'm going to get minus 4y. Now I want to divide this by n, okay? I want to divide by n. What is my n? My n is 2xy. So if I divide by n, so I'll just write n over here. If I divide by n, that means 2xy. So the y gets cancelled and I'm left over with a minus 2 by x. And you can see this is definitely just a function of x, right? So that means rule number 1 has satisfied. I have got this quantity as a function of x. So now I can say that my integrating factor is going to be e to the power integration of the particular function that I have got. So that's minus 2 upon x dx, right? So if I integrate this, I'm going to get e to the power minus 2 log x, right? Now what I can do, I can take this minus 2 and raise it to the power of x. So it becomes e to the power log x to the power minus 2, right? So e to the power log, that's going to get cancelled out and we are going to be left with x to the power minus 2. That's basically 1 upon x square, and this is our integrating factor, right? So we have found our integrating factor. Now the moment you have got the integrating factor, now the steps are simple to follow. The step is that now we need to multiply this integrating factor with the given differential equation. Okay, so I'm going to multiply this on the both sides of the differential equation. So my equation is x square minus y square dx plus 2xy dy. I hope I've copied it correctly. Yes, so this is my differential equation. I want to multiply it with 1 by x square. So I am multiplying with 1 by x square, and right hand side remains 0. I have multiplied that with also 1 by x square and it remains 0, right? So now if I little bit simplify this, it turns out to be 1 minus y square by x square dx plus, here I can cancel out 1x, so I'll be left with 2y upon x dy equals 0. So now this is my differential equation, which I can say that it is definitely exact. Okay, you can check this. Okay, now you can again consider this as your new m, or which we told as p. You can consider this as your p and you can consider this as your q. Okay, as per the rule, I'll just show you over here. So you can consider this as your p and this as your q, the new terms which have formed after the multiplication. And if you check, this is definitely going to satisfy the exactness criteria. Okay, the partial derivative of this with respect to y, partial derivative of this with respect to x is going to be equal. We don't need to check that. Okay, we know that's definitely going to happen because that's the work of the integrating factor. It makes the thing exact. Okay, so now we're just going to solve this. We'll just say that this is exact. We know that, and now we're going to solve it. Okay, so now remember, the solution process is same as what we have done in lecture 1. Okay, so since this is exact, so I'm going to integrate this particular thing with respect to x, treating y as constant, right? So if I do this integration treating y like a constant and with respect to x, integration of 1 becomes x minus y square, it remains like a constant. I just have to integrate dx upon x square, right? So this is x minus y square, integration of x to the power minus 2, that's x to the power minus 1 upon minus 1. So it becomes plus 1 by x, right? So this is one of our integration. Moving on to the next integration. Okay, so I'm moving on to this integration. So I'll be having integration 2y by x dy, where x as constant, right? So if x is constant, I can just bring out 2 upon x and I have y dy. So if I integrate this, I'll have y square by 2. The 2 will get cancelled and I have y square by x. Okay, so I have got the two terms. Now I hope you remember how we write the general solution. The general solution would be written as, you just copy the first term that you have got from the integration. That means you just copy out this one. So you get x plus y square by x. Now plus, we are going to write the terms from the second integration, provided if they are not already written. Okay, but you can see this term is already written from the first case, so we are not going to copy the same thing twice. So we are just going to have this as our final solution. So that means we're going to write this equals c, where c is our integrating constant and this is our final answer. Okay, so I hope this makes sense, and I'll move on to another question. Okay, so this is the question we are going to solve. So if you have understood the process, you can pause the screen here, try out the problem, and then check the answer later. Okay, so in this question, we can see that this is our m part, and including the minus sign, x square y is our n. So let's do the derivative directly. So del m del y, that's going to be 2xy partial derivative of e to the power 1 by x cube with respect to y, that's 0, right? And del n del x, so that's going to be minus 2xy. We can see that both are not equal, right? So hence we can say that it is not exact. So let's find the difference of the two, del m del y minus del n del x, and I'm going to divide that by a n. So the subtraction of this two, that's going to be 4xy, and divided by n, n is minus x square y, so minus x square y. So if I cancel out the y, we are going to be left with minus 4 upon x. So this is a function of x, right? So we have got function of x. That means rule number 1 is satisfied. So we can say that the integrating factor is e to the power integration of the function of x that we have got, which is minus 4 upon x dx. This integration would become minus 4 log x. Then just like before, we can take the minus 4 in the power of x, so it becomes e to the power log x to the power minus 4, and finally we have 1 by x to the power 4 as our integrating factor, right? So now again, same as before, we're going to multiply the integrating factor on the both sides of the given differential equation. So if I multiply on both sides, so I'll be having xy square minus e to the power 1 by x cube, this into dx minus x square y dy equals 0. So this is our original differential equation. I'm going to multiply both sides with a 1 by x to the power 4. So I'm individually dividing each term by an x to the power 4. That would make my calculation more easier. So now if I just simplify the terms, I'm going to get y square upon x cube minus 1 by x to the power 4 e to the power 1 by x cube. This goes into the integration. Okay, I'll do the integration later on. Let me just simplify it for now. So this into dx minus y upon x square dy equals 0. So this is our exact differential equation. So now I can say this is my exact differential equation. And now again we will be solving our exact differential equation like before. So I'm going to do integration of this term, which is y square upon x cube minus 1 by x to the power 4 e to the power 1 by x cube dx, treating y like a constant, right? So if I do this integration, so y square just goes out. I have to do integration of 1 by x cube dx, which is integration of x to the power minus 3, and that would be minus 2x square, right? And then for the next part, so integration for this portion, I have to do some substitution to do this integration. So I can see that if I substitute, I'll do the substitution here. Let's say I'm taking 1 by x cube as z, right? So if I do this substitution, if I do a derivative both sides, so this is x to the power minus 3. Upon doing this derivative, I would have minus 3 by x to the power 4 dx equals dz. So that would mean and minus 1 by x to the power 4 dx equals 1/3 dz. So I can substitute this in the integration, right? So if I substitute this, so I can see I have a minus over here, so that means this minus will get absorbed, so that would become plus 1 by x to the power 4 dx, that would become 1/3 dz, and I'm left with e to the power 1 by x cube, so that would become e to the power z, right? So this would become e to the power z. So now if I complete the integration, I have minus y square by 2x square plus 1/3 integration of e to the power z would be e to the power z. So e to the power z is 1 by x cube, 1 by x cube. So this is the integration of the first portion. Now I'm going to do the integration of the second portion. So this portion I'll be doing the integration. So integration of minus y upon x square. So now I'll be doing integration of minus y upon x square with respect to y, treating x as constant, right? So if I do this integration, I can bring out the x outside. So basically minus 1 by x square outside. I have integration of y dy. Integration of y dy would be y square upon 2. So that means minus y square upon 2x square. So this is the value from the second integration. Okay, so now I'm going to combine this two and get my general solution, and also I can observe that these two terms are actually the same. So I can say that the general solution is given by, I'll take the value from the first integration, which is minus y square upon 2x square plus 1/3 e to the power 1 by x cube. This term is already present, right? The second integration, the term is already present in the first integration, so I'm not going to take that again. So this equals to c, and that is my final answer, right? So this is how we are going to deal with non-exact differential equation, finding integrating factor using rule number 1. Now let's go to another rule, rule number 2. Rule number 2 is saying again the same subtraction, del m del y minus del n del x, but now instead of dividing by n, if I divide by m, and if the result is that it is a function of y, not a function of x anymore, it's completely a function of y, then the integrating factor is again in the same style, e to the power, just make sure there is a minus in this case. Okay, in the previous case there was no minus, in e to the power minus integration of whatever function of y we have got, right? So again, another easy way to remember this would be, we are differentiating m with respect to y, so when I am dividing by m, so the output should also be a function of y. Okay, so m is connected with the derivative of y, so if I divide by m, the function also has to be a function of y. So this is an easy way to remember, and the integrating factor will have a minus sign. Again, that's something to remember. Okay, so let's take a look at a question. So first we need to again check whether this is exact or non-exact. Definitely it's not going to be exact, but we have to check every time. Okay, so this is our m, this is our n. I'll just fast track the calculation here. So del m del y, that would be 12x square y cube plus 2x del n del x, that would be 3 to the 6 x square y cube minus x square would become minus 2x. So obviously we can see both are not same, so I need to take the subtraction of the two. So del m del y minus del n del x. If I do this subtraction and divide it by m, then the subtraction I'm doing that directly. So 12x square y cube minus 6x square y cube, the subtraction of the first two terms, that's going to be 6x square y cube, 2x minus of minus 2x, so that would become addition. So basically 2x plus 2x, that becomes plus 4x, divide by m. M is this term, which is 3x square y to the power 4 plus 2xy. Now remember, this has to be a function of y to implement the rule. But here directly you might sometimes see that things are not cancelling out, x is still present, but be careful over here. Take something common from numerator denominator, maybe things are going to get cancelled out. So let's see, if I take let's say a 2x common. Okay, if I take a 2x common from the numerator, so I'm going to be left with 3xy cube plus 2, right? and from the denominator if I take xy common, so I'm going to be left with 3xy cube plus 2. So you can see 3xy cube plus 2 is getting cancelled from numerator denominator. 1x is getting cancelled. I'm left with 2 upon y, which is a function of y. So that means rule number 2 has been satisfied, right? Now what will be our integrating factor? So my integrating factor is going to be e to the power, remember to give the minus sign, minus integration of whatever function I have got, which is 2 upon y dy. The integration would be e to the power minus 2 log y. We have done this kind of simplification many times before, so this is going to be 1 upon y square. That's my integrating factor, right? Now again the same process will follow. We'll multiply this on both sides of the equation, integrate with respect to x and y, then finally find the general solution. So first I will multiply the given equation with this term. I'll individually divide each term by y square. So my new equation would be 3x square y to the power 4 plus 2xy whole dx plus 2x cube y cube minus x square dy equals 0. So this is my original equation. I'm dividing by a y square, so I'm dividing each term by a y square, and if I simplify this one more line, so I'll have 3x square y square plus 2x by y dy plus 2x cube y minus x square by y square dy, right? Y square dy equals 0. So definitely this is now my exact differential equation, right? So this has become exact. Now again the same process for solving. So I'm going to integrate this particular term. Achha, I have written this wrong, pardon me. So this is dx, not dy, right? So I'm going to integrate this with respect to x, treating y as constant, right? So if I do this integration, I'm going to get so x square integration is going to be x cube by 3. The 3 will get cancelled, so I'll have x cube y square. Then again integration of x would be x square by 2. The 2 will get cancelled, so plus x square by y. So this is the value from the first integration. Now I'm doing the second one. So second one is 2x cube y minus x square by y square dy, treating x as constant. And if I do this integration, so integration of y would be y square upon 2. 2 will get cancelled, so x cube y square. Integration of 1 by y square, that means y to the power minus 2, that's minus 1 by y. So minus minus, it will become plus x square by y. This is my second integration. I can see both the integrations are giving me completely same answer. So that means my general solution is going to be x cube y square plus x square by y. So I'm just going to take it once because the same terms are again repeated in the second integration, equals c, and this is my final answer. I hope that's clear. So let's quickly move on to our next question. So this is a pretty long question, okay? So again, you can pause the video here, try it yourself, then match the answer with me, okay? So let's start by partially differentiating m with respect to y. So now we have to be careful. You have to do a product rule for derivative over here, okay, because there are two y terms involved. So 2x is a constant, no issue with that, but derivative of y to the power 4 e to the power y, we have to use the u into v method for derivative. So first I'm doing the derivative for y to the power 4, that would be 4y cube, and e to the power y stays, plus y to the power 4 remains as it is. Derivative of e to the power y would be e to the power y, okay. Going to the second term, so that's going to be 3 to the 6x y square, and lastly 1, right? So I'll just multiply this. I don't want to keep it this way. So 8xy cube e to the power y plus 2xy to the power 4 e to the power y plus 6xy square plus 1. So that's my del m del y. Now coming to del n del x. So if I partially differentiate this with respect to x, I'll be getting 2x y to the power 4 e to the power y, then x square would be minus 2x y square, minus 3x would become minus 3. So obviously both are not same, that means it's not exact. So let's find the difference of the two. So del m del y minus del n del x, and I'm going to divide that with an m. Now at this stage you might have a question that why are we dividing by m, why not by n, or how do we understand should I divide by n or should I divide by m? Well, to answer that question, you cannot predict that from beforehand. Okay, you have to find the subtraction, divide it by n in your rough work or divided by m in your rough work, and see whether they are turning out to be function of x or y only. If that's working out, well and good. Otherwise we still have 3 more rules remaining. Okay, now it's my common observation. Okay, I'm not saying it happens 100% of the times, but I have seen in many questions, I would say 80% of the questions that comes in the exam, because this video series is mostly focused on exam. So questions which generally come in the exam, I have a small observation for that. For rule number 1, see, specifically I'm talking about rule number 1, you will see when you are doing the problem of rule number 1, the difference, or I would say del m del y and del n del x, they generally have a difference of sign. Okay, they generally have a difference of sign. One is negative, one is positive, rest thing is same. When you have just a difference of sign, it is a general observation that it falls under rule 1. I'm not saying always it happens, but it's a general observation. Okay, it happens 80% of the times. Okay, so that's one hint you can keep in your mind. If del m del y and del n del x differ by only a positive or a negative sign, there are high chances that rule number 1 is going to work out. Similarly, if you look at the second question that we had solved, the second question, again you would see 2xy and a minus 2xy, just a difference of sign. But when we are doing the second rule, that is not happening. Okay, when we are doing the second rule, the difference is completely different, right? It's not just difference of sign, it's difference of other multiplicative terms as well. Okay, so it's a common observation which I have shared with you. You might want to experiment with that. Okay, so coming back to the question, so if I do the subtraction, I'll directly do the subtraction. I can see that I can subtract these two terms. Okay, these are similar kind of terms, so upon subtraction this term and this term would cancel out, right? Again, these two are similar kind of terms. So this term is completely independent, like there's no other similar term to this one, so I'll just copy it out. So it's 8xy cube e to the power y. These two terms have cancelled out upon subtraction. 6xy square minus of minus 2xy square, that would become addition, so plus 8xy square. Then 1 minus of minus 3, that would become a plus 4 divided by m. My m value is 2xy to the power 4 e to the power y plus 2xy cube plus y. Okay, again let's try to see whether we can cancel out something from numerator and denominator. Well, again we will try to take a few things common. Let's take 4 common from the numerator. So if I take a 4 common, I have xy cube e to the power y plus 2xy square plus 1. From the denominator, what I can do is I can take a y common, right? Which I missed a 2 out here. So if I take a y common from the denominator, I have 2xy cube e to the power y plus 2xy square plus 1, right? Again, you can see numerator denominator is same, so they will simply get cancelled out. We are left with 4 upon y. That is our function of y. So rule number 2 has been satisfied, right? So now I can say that my integrating factor, I'll do the calculation here. My integrating factor would be e to the power minus integration of whatever function of y I have got, which is 4 upon y, 4 upon y dy. So that would be to the power minus 4 log y, and that would give me 1 by y to the power 4 as my integrating factor, right? Now again, same as before, I'll multiply the entire equation with 1 by y to the power 4, and let's see what we would get out of this. So I'll just copy out the main equation first, which is 2x y to the power 4 e to the power y plus 2xy cube plus y plus x square y to the power 4 e to the power y minus x square y square minus 3x whole dy. Then I'm going to divide each term over here with y to the power 4, which is our integrating factor. So by y to the power 4, by y to the power 4, by y to the power 4, and so on. So if I simplify this, I'll be having 2x e to the power y plus 2x by y plus 1 by y cube dx plus x square e to the power y minus x square by y square minus 3x by y to the power 4 dy equals 0, right? So we have got our exact equation. Okay, so this is our exact differential equation. Now we are going to integrate this like before. Okay, so I'll integrate the first part, this part, integration of 2x e to the power y plus 2x upon y plus 1 by y cube dx, treating y as constant. Okay, so if I do this integration, y is constant, so this would be x square by 2, 2 will get cancelled, so it's x square e to the power y, again x square by 2, 2 will get cancelled, plus x square upon y, and there's no x here, so that would give me plus x upon y cube. That's the value from the first integration. Now I'll go for the second one. So integration x square e to the power y minus x square by y square minus 3x by y to the power 4 dy, treating x as constant, right? So now again, integration of e to the power y would be e to the power y, so x square e to the power y, integration of 1 by y square, so minus would become plus x square by y, again y to the 1 by y to the power 4, so that would minus would become plus 3. The 3 will get cancelled from numerator denominator after the integration, so x upon y cube. That is what we are getting from the second integration. We have all the terms common from both the integration, so that would mean that my general solution is given by just the first values from the first integration. That would be enough because we have got the same values again from the second integration. So this equals to C is my answer to the question, right? So that's rule number 2 done and dusted. Okay, moving on to rule number 3. Okay, now this rule is identifiable by just looking at the question. Okay, you can look at the question and you will understand whether rule number 3 is going to be applicable or not. Unlike the first two rules, in the first two rules you couldn't make that out whether to use rule 1 or rule 2 just by looking at the question. You have to do a few calculations to understand that. But for rule number 3, that's not the case. So let's see what this is saying. It is saying that if m and n are both homogeneous functions, okay, so we need to understand what is a homogeneous function. Homogeneous function in x and y of the same degree, okay, definitely same degree, not different degrees, and if mx plus ny, if this quantity is non-zero, okay, why is it required to be non-zero? Because the reciprocal of this is going to be our integrating factor. So definitely if this is 0, so 1 by 0 would become undefined. So we need to make that correct. So we need to make sure it is not becoming 0. Generally it doesn't become 0 when a question we have from rule 3, definitely never becomes 0. So if it is non-zero, then 1 upon mx plus ny is our integrating factor. Now let's understand what is the meaning of homogeneous function. Suppose I have a function, let's take an example, x square y cube plus y to the power 5. Is this homogeneous or not? Yes, it is homogeneous. How to understand it? Look at the total powers of the terms. Okay, what is the total power or what is the total degree? Okay, the total degree of this term is x has a power of 2, y has a power of 3. The terms are multiplied, that means the powers are going to get added. Okay, law of powers. If you multiply the variables, the powers get added in order to find the degree. So the degree is how much? 5. This term has degree how much? It is directly 5. So both the terms have same degree. That means all the terms present in this function has same degree. That means this function is a homogeneous function. For suppose if this function had another term, let's say x to the power 3 into y. Okay, then what would be the degree of these two terms combined? Degree 3 plus degree 1, so degree 4. So now we have a mismatch, degree 5, degree 5, degree 4. So there is a mismatch of degrees. If there is a mismatch of degrees, that means it is not homogeneous. For a function to be homogeneous, all the terms should have a same degree. Okay, so now here it is saying that m has to be homogeneous and n also has to be homogeneous, and both of them has to be homogeneous of the same degree. Okay, now the mathematical version to find out whether a function is homogeneous or not. So this is just, you can understand whether it is homogeneous just by observation. But let's say if you have this question and it is asking you that show that it is homogeneous. Okay, how to show or how to prove whether something is homogeneous? The property is, replace whatever variables you have. Here we have the variables x and y, right? We have the variables x and y. So replace x with a tx and replace y with a ty. Then if t to the power n comes out common completely and you are left with only the original function, which is f of xy, if the t fully comes out common, then it is homogeneous, and whatever power of t comes out common, that power is the degree. Okay, so let's apply this over here. So if I replace x with tx and y with ty, so it would become t square x square into t cube y cube plus t to the power 5 y to the power 5, right? I have replaced my x with tx, y with ty. Okay, so I can see a t to the power 5 will come out common completely, and I'm left with x square y cube plus y to the power 5, which is nothing but my original function. So that means t to the power 5, the original function has come back. So it is satisfying this property. So that means this is a homogeneous function of degree 5. Okay, so if you had some uneven degree term associated, then the entire t would not have come out common, and hence you could say that it is not homogeneous. Okay, so now this is easy to observe, right? You just look at the powers. If they are all same, you understand it is homogeneous. So if m and n are both homogeneous, having same degree, you directly understand it's going to be rule number 3 with your eyes closed, right? So let's take a look at a question. So if you just observe the question very carefully, you can see this term is degree 4, this is degree 4, this term combined is x has a power of 1, y has a power of 3, so degree 4. So your m has degree 4, your n has degree 4, so both are homogeneous of same degree. You understand it just from observation. Okay, no need to do a calculation and prove that it is homogeneous. You can just claim that here we can see the given differential equation is homogeneous of degree 4. That's it. Okay, so directly we can start with our integrating factor, right? We can see our integrating factor is 1 upon mx plus ny, provided it is not 0, and definitely for these kind of questions they are generally not 0. Okay, if it becomes 0, then this way is not going to work out. You have to do some other method. Okay, so we are not going to discuss that right now. So now one more important thing over here is that you can see for this particular question, you don't have to find out del m, del y, del n, del x. These terms you don't have to find out because it is not required in the integrating factor. So just from observation, you have understood it is rule 3. You directly find out the integrating factor this way. You don't require the partial derivatives. So this method is basically saving you a lot of time. So I would get 1 upon, this is my m part, m multiplied with the x would be x to the power 5 plus y to the power 4 into x. So this is by mx part plus n is including the minus sign. So it's a minus x y to the power 4, and I can see these two terms are getting cancelled out. So I'm left with 1 by x to the power 5, which is my integrating factor, right? So the moment we have got integrating factor, now again the same style of solving is going to follow. I'm going to multiply the given equation with the integrating factor. So my equation would become x to the power 4 plus y to the power 4 dx minus xy cubed dy equals 0. Multiplying it with integrating factor, so dividing each term manually by x to the power 5, which is my integrating factor, and this would turn down into 1 by x plus y to the power 4 by x to the power 5 dx minus y cube upon x to the power 4 dy equals 0. So now this equation has become exact. Again, same process of solving is going to follow. So this is now exact, right? So now I'm going to find out integration of this portion, 1 upon x plus y to the power 4 by x to the power 5 dx, treating y as constant. So this would become log x plus I'll have a minus sign, minus y to the power 4 by 4x to the power 4, right? Going on to the second integration, so that would be integration of minus y cube by x to the power 4 dy, treating x as constant, and this would be minus 1 by x to the power 4 goes outside, integration of y cube, that will be y to the power 4 by 4. So this is basically minus y to the power 4 by 4x to the power 4, which is exactly same as one of the terms from the first integration. So I can say that my general solution is given by just copying the terms from the first integration, which is log x minus y to the power 4 by 4x to the power 4. This term is already present here, so not copying it again, equal to c, and that is my final answer, right? So I hope this makes sense. Moving on to the next question. So again, you can pause the video, try it on your own, okay, and then later check the answer with me. So here again we can see that this term has degree 3, this term combined has degree 3, this term combined has degree 3, this term is directly degree 3. So it's completely homogeneous of degree 3. So that means rule number 3 is applied. See, it's so simple, right? So that means my integrating factor would become 1 upon mx plus ny. So that means 1 upon, this is my m part, so I'm going to erase the degrees here. This is my m part, so m into x would be xy cube minus 2 x cube y, plus this is my n part, so n into y would be 2xy cube minus x cube y, right? Let's see we are getting something cancelled or not. So I have xy cube, x cube y, x cube y, two similar terms, they are going to get added, and again these two terms are also going to get added, so nothing is getting cancelled out over here. So we are having 3xy cube, and these two terms added up would become minus 3x cube y. So we can take a few things common to make things easier for ourselves. So I can take a 1 by 3xy common, and I would be left with a y square minus x square, right? So this is my integrating factor. Okay. So now you can multiply this with the given equation on both sides, and then again integrate term by term like before. So I hope you will be able to do that. I'm not doing the repetitive calculation again and again. So this you can try on your own, or you can treat it as a homework. Okay. I'll move on to the next rule that we have, which is rule number 4. Okay. Now rule number 4 is again kind of rule number 3, where you can identify by looking at the question whether it is going to be the question is going to fit into rule number 4 or not. Okay, you can identify that by just looking at the question, just like rule number 3. Okay, so now the differential equation has to be of the form, you need to remember this format of writing: y taken common, function of xy dx, x taken common, function of xy dy. Okay, here f is some function of xy, g is again some other function of xy. Now what does a function of xy mean? Function of xy means something of this form. Let's say xy whole square plus 2 times xy plus 5. Okay, so this is a function of xy, right? Every term is created with the help of x into y. Okay, you cannot have terms like x square y. This is not a function of xy, because you have you can split this into x into xy. Okay, so you have one xy term and one only x, so that's not a function of xy. If something is a function of xy, all the terms has to be created with xy. Okay, so if you can arrange the differential equation in the format y common, then some function of xy, again g common, some function of xy associated with dx dy, and again now if mx minus ny is not non-zero, okay, previously it was mx plus ny, here if mx minus ny is non-zero, then the reciprocal of that is going to be our integrating factor, and again solution like before. So now in this question you can see that y is taken common, which is associated with the dx term, and you have terms which are function of x into y, right? xy and then 2 times xy whole square, so that's a function of xy. So again x common with the dx part, function of xy, function of xy. So this is fitting into rule number 4. So that means directly you can say that your integrating factor is going to be 1 upon mx minus ny. Okay, now this entire thing is your m part, this entire thing is your n part. Okay, so when I'm going to do m into x, so basically I'm multiplying an x over here and I'm multiplying a y over here. Okay, so mx and ny. So that means from both the terms you can see you can take a xy and a xy common, right? So upon multiplication m with x and n with y, you get xy common in both the cases, right? So I'll directly do that over here. I will take the 1 by xy common right at the beginning. So that means this xy has been taken common. I am just left with the function of xy inside. So that means xy plus 2x square y square. And here also I've taken the xy common, right? So I have to take the minus and whatever is the function inside, which is xy, then minus of minus becomes plus, plus x square y square, right? So I can see xy getting cancelled and my function becomes 1 upon, this becomes 3 times x square y square multiplied with the xy. So that means 1 upon 3 x cube y cube, and that's my integrating factor, right? Now again, like before, I'll solve this, multiply the given differential equation with the integrating factor. So I'll just copy out the differential equation. So I have xy common. And so this x was not there actually in the original question, it only comprised of the y part. I had multiplied x for finding the mx part. So remember that this x is not there, this y is not there in the actual differential equation. Okay, so I'll copy the actual one. So I'll multiply this y inside with each of the terms. Okay, I'll multiply the y which is outside. So it would become xy square plus 2x square y cube whole dx. And I'll just copy this down. Then next one, again I'll multiply this x inside, so it would become plus x square y minus x cube y square dy equals 0. Now I'll multiply with the integrating factor. The integrating factor is 1 upon 3x cube y cube by 3x cube y cube by 3x cube y cube, and so on. So if I simplify this one more line, I'm going to get the y square and the x will get cancelled, so I will have 1 by 3x square y plus 2 by x whole dx plus again 1 by 3xy square minus 1 by 3y dy equals 0. And now this is definitely an exact differential equation, right? Now, like before, I'll integrate the terms. Okay, so I'll be doing the integration of the first part, integration 1 by 3x square y plus 2 by x dx, treating y as constant. So this would become, so the 3y will actually be going outside. I just have to do the integration of 1 by x square. Integration of 1 by x square would be minus 1 by x plus integration of 2 by x would be 2 log x. So I basically have minus 1 by 3xy plus 2 log x, right? This is the value from the first integration. Now going for the second integration, which is integration 1 upon 3 xy square minus 1 by 3y dy, treating x as constant, right? So again, x constant means 1 by 3x goes outside. Integration of 1 by y square, that would be minus 1 upon y, and the next would be 1 minus 1 by 3 log y. So I basically have minus 1 by 3xy minus 1/3 log y. So one of the terms over here is common and the other terms are different. So that means I can say that my general solution is given by, I'll copy the first values from the first integration, 1 by 3xy plus 2 log x. I'll not copy the same term again, so I'll focus on the next one, which is minus 1/3 log y equals c, and that's the answer of this particular question, right? So let's move on to another question. I will not completely solve this question, okay? I'll just help you visualize it and then move on. Okay, so again you can see that this is directly not in the format, okay, but here the power of y is 1 ahead of the power of x, right? In this case the power of x is 1 ahead of the power of y. That means if I take y common from the first part and x common from the second part, they're going to become functions of xy, right? So if you make this observation, so if I take y common from the first part, I'll have x cube y cube plus x square y square plus xy plus 1 whole dx. And if I take a y common from the second one, so if I take a x common, so x cube y cube minus x square y square minus xy plus 1 dy equals 0. And you can see this is a function of xy and this is again some other function of xy. So that means rule number 4 has become satisfied, and now I can say that my integrating factor is going to be 1 upon mx minus ny, right? Mx minus ny, right? 1 upon mx minus ny. Okay, now mx, as I told you, remember, if you multiply this with the x, it becomes xy. If you multiply this with a y, this becomes xy. So basically you can take xy fully common, just like I've done in the previous question, right? So if xy taken common, I have these terms. So basically I have this minus this, right? I have this minus this, okay? So if I do the subtraction of this and this directly, mentally, okay, without writing, mentally, so x cube y cube minus x cube y cube, that gets cancelled, right? X square y square minus of minus x square y square, that gets added up, so 2x square y square. Xy minus of minus xy, again that gets added up, so plus 2xy. 1 and 1 is again getting cancelled out, so that means this is my integrating factor. I can simplify this one more line. I can take a 2xy common, so 2x square y square completely common outside, and I am left with xy plus 1. And now again you are going to multiply the integrating factor on the both sides of the question, integrate term by term, get the answer. So again I'm leaving that as your homework, which you can do, right? And you can comment me the answer. I'll verify it for you whether that's correct or not. Okay, so moving on to our last rule. Okay, now for the last one, take a deep breath because it's going to be a big rule, a little bit complicated rule. Okay, so take a deep breath, take a pause, take a break, and come back, and let's continue with rule 5. Okay, so rule 5, it's a lot of things are happening over here. Let's be a little slow to understand what's happening. First of all, we have the differential equation in our form, which is m dx plus n dy equals 0. Now, if we can arrange this differential equation in the form which looks something like this. Okay, I'll go into the explanation a little bit later. If we can do it, okay. Now a lot of unknown terms are involved over here. What are the unknown things or things we need to find out? A, B, M, N, A dash, B dash, M dash, N dash. These are the terms we need to find out. Okay. Now once those we have found out, then the integrating factor is x to the power h, y to the power k. Now where is this h and k coming from? Basically, once you have found out a, b, m, n, a dash, b dash, m dash, n dash, you take those values, put it in these two equations. Okay, so basically you know the value of a, you know the value of m, you know the value of b, you know the value of n. So your unknowns are h and k. So from here you create an equation with h and k. Again, you know the value of a dash, you know m dash, you know b dash, you know n dash. Then again your unknowns are h and k. So basically from these two things you are creating two equations of h and k. So when you solve these two equations, you get the value of h and k. Now x to the power h, y to the power k, that is your integrating factor. Okay, so a lot of things are happening. Now let's be very careful about how the format should look like. Okay, there are some complications here. Remember, one easy way to remember this is dx has to be associated with only y. Remember, y, only y, not y square, not some other term of y, only one single y, and it can be followed by a constant, not more than that. M is a constant. Now see, maybe in some particular question, let's say this m value is 2, this n value is also 2, so someone might have a tendency to take the 2 common outside and write it over here. That will become wrong. Remember, you have to maintain this format that all the constants have to be inside. There cannot be any constant outside. Outside there cannot be any constant, although you might be able to take it common, but don't keep it inside. Don't take the common factor outside. Okay, so that we can match it with this format. So on the outside you should only have x to the power something, y to the power something, any power of x and y, doesn't matter. Some power can be 0 also, no problem. Dx associated with only y followed with a constant, dy associated with the only x, and a constant is allowed with that. Same thing again repeated. Okay, same thing again repeated. Dx with a y, dy with a x, they can have two constants, x to the power some power, y to the power some power. Now when you have arranged it in this format, you will know what is your a value, b value, m value, n value, a dash value, b dash value, m dash value, n dash value. These you will get to know the moment you have arranged it in that format. Use these values and plug it into these two equations. Okay, now you have to memorize these two equations also. A plus h plus 1 by m, b plus k plus 1 by n, a dash plus h plus 1 by m dash, b dash plus k plus 1 by n dash. Plug in those values in these two equations, so you basically get two equations of h and k. Solve those two equations, you get the value of h and k. When you have got the value of h and k, put it in the power of x and y respectively, and that is your integrating factor. Okay, so a lot of things are happening. Let's take a look at a question. Okay, so this is our question. What we can do over here is that first we have to identify as you can see in the format, you have to break it up into two parts. This is one part, this is another part. You have to essentially break it up into two parts. There are two dx terms, two dy terms. You have to break it apart. Okay. So now the common question is how to match the terms. Which terms should be paired up with which term? That's a basic question. So first what we will do is, remember, as I told you, dx has to be associated with a y. Okay. So focus on the dx term. Let's focus on the dx term and let's take one y common with it. Okay. So upon this multiplication, I am keeping the y and the dx. Okay. What's the constant? Remember, I told you, you cannot keep the constant as outside. You have to keep the constant along with the y. The constant is 3. So write a 3. Right. So I have associated dx with one y. So now what is left out? I have x square and y to the power 3 is left out. So write it outside. X square, y to the power 3. Okay. So basically if you multiply this two, you just get the first term. Now think again which term is going to give you x square y cube common. Okay. Look out for it. You can see over here you can take x square y cube common. You cannot take that common from the second term. You can only take it common from here. So now you get an idea that this must be connected with this term. So we are going to pair them up. Okay. So if you take x square y cube common from here, what are you left with? You are left with 2x. Okay. So you are left with 2x and dy is associated with it. Dy. So that means what have we done? We have paired this term and created this two. So if you multiply, you'll get this term and this term. So definitely now the two remaining terms have to be paired up, right? So now again I need to write dx. If I take dx, I need to have a y along with it. So I have taken y dx. I need to associate the constant also. Okay, so the constant part is 2. So I've taken 2y dx. What am I left with? I'm left with only the x. So keep the x outside, right? So now again, if I take that same x common from here, so again one x is going to be left. So there's a minus sign, minus x dy. So you can see if you multiply this, you're going to get this term and this term, right? Now see, this is completely matching with our format, which is x to the power a, y to the power b, y dx plus nx dy plus x to the power a dash, y to the power b dash, m dash y dx plus n dash x dy equals 0. It's completely matching with the format. So let's compare this two and find out the constants. Okay. So if I compare, I can see a is same as 2, right? So a value is 2. Okay. B is same as 3. So b is 3. M is 3, right? So m is 3. N is 2. So n is 2. We have got the first set of values. Now coming to the next part, a dash. A dash is how much? A dash is x power. Nothing is there. That means 1. So that means a dash is 1. B dash, y is not present at all. So y is not present means y to the power 0, right? Y not present. So that means b dash is how much? B dash is 0, right? So b dash is 0. M dash is 2. M dash is 2. And n dash, that's minus 1, right? So n dash is minus 1. So we have got the constant values. Now we are going to form our equation, which is a plus h plus 1 by m equals b plus k plus 1 by n. So if I plug in this set of values over here, I will getting a plus 1, that means 2 plus 1, that's 3, plus h by m, which is 3. B is 3, so 3 plus 1, that's 4, plus k by n, that's 2. So if I just cross multiply, 6 plus 2h equals 12 plus 3k. So I would get 2h equals 6 plus 3k, right? So let's keep this equation. Again, we know another set of equation is going to be Just a similar looking one with the dash terms, a dash h plus 1 by m dash equals b dash plus k plus 1 by n dash, right? So again, I'm going to plug in these values over here. A dash is 1, so 1 plus 1, that's 2, 2 plus, sorry, so that's 2 plus h by m dash, that's 2 equals, b dash is 0, so 0 plus 1 is 1, plus k, which is unknown, by n dash, which is minus 1, right? So again, if I just cross multiply, I'm going to get minus 2 minus h equals 2 plus 2k, right? So that would give me h equals, so I'll just find the value of h from here and plug it back right here. So h would be minus 4 minus 2k, right? So if I plug in this value of h right over here, what I'll be getting is 2 times minus 4 minus 2k equals 6 plus 3k. So that is minus 8 minus 4k equals 6 plus 3k, and that would be 7k equals 4 minus 14. So that means k equals minus 2, right? So now the moment I plug in this value of k right over here, I'll be getting the value of h. So if I plug in minus 2, so that becomes minus 4 plus 4, so h value is 0, right? So I've got the value of h and k. Now remember, what was our integrating factor? Our integrating factor was x to the power h, y to the power k, which is x to the power 0, y to the power minus 2. So that means 1 by y square is my integrating factor. Now you might be thinking, my integrating factor is a function of y. So that means this must have been rule number 1, rule number 2. Remember, rule number 2 was, what was rule number 2? It was 1 by m del y minus del n del x equals function of y. If we get function of y, then our integrating factor would be e to the power minus integration fy dy. And actually, if you had applied this rule in this particular question, you would have got this same integrating factor. You can check that out for yourself as a satisfaction. Now you might have a question that, then why are we taking so much pain to do rule number 5 when it can already be done with rule number 2? Well, my friend, the thing is, this was an easy sum, okay? The first sum, I have selected an easy one. That's why your h turned out to be 0. Your h turned out to be 0. So integrating factor just became a factor of one variable. So it went back to rule number 2, right? But there are going to be questions where none of h and k are going to be 0. Both are going to be non-zero. When both are non-zero, sometimes you'll have fractional values also. H equals to some fractional value, k equals to some fractional value. If you plug in the fractional values, your integrating factor is going to look like x to the power half, y to the power 3 by 2. Okay, these kind of fractions. So those things you will never get from rule 1 or rule 2 or any other rule. It will be an exclusive rule 5 question. Okay. Alright, so let's again continue. So we have got the integrating factor as 1 by y square. Okay, so now again we can just multiply 1 by y square with the given question, right? This was our given question. You can multiply both sides by the integrating factor and solve as before. Again, I'm not going into that. It's simple repetitive calculation. I'm skipping it, going on to another question. Okay. Now again, let's try to do this question. Now one more important thing I have to tell over here. Since over here in this video, I'm explaining the rule, doing a respective question. But in your exam, if you get this question, you will never know that you have to do it with rule 5 or any other rule. So remember this, whenever you get a question like this is your m, this is your n. First, how you will approach the question. Okay, so this is going to be a last question. So I'm summarizing everything, how to approach a question in the exam hall. First, look at the question and decide, is this homogeneous or not? That means, is this going to be rule 3 or not? Okay, This is y square degree 2, this is x square y degree 3. Instantly we have a degree mismatch. That means it is not homogeneous. That means rule number 3 is out of the picture. Let's now think about rule number 4. Basically the rules that can be observed from the question. If for rule number 4, if I take y common, that means I will be left with y plus 2x square dx, and I'm not writing the other part. So this is not a function, this is not a function of xy, right? This is not a function of xy. So that means rule number 4 is also out of the picture. The moment rule 3 and 4 are out of the picture, so first you need to check rule 3, then you need to check rule 4. When both are out of the picture, now you still don't know whether it is rule 5 or maybe rule 1 or rule 2. So your best bet would be to find out whether it is rule 1 or rule 2, because you will always want it to be rule 1 or rule 2. You will never want it to be rule 5. Rule 5 should be your worst case scenario. Okay. So you find out these two quantities, definitely they will be not equal. So you find out their subtraction, okay? You find out their subtraction, you divide this by a m and you check whether it is a function of y or not. You divide it by, or maybe another possibility is you divide it by a n and check whether it is a function of x or not. If that is happening, then it is going to rule 1 or rule 2 respectively. If these two things are also not happening, now you know that this is rule number 5, and then only you do rule number 5. Okay, otherwise you don't directly start a question assuming it to be rule number 5. Understood? Okay, so let's do this question as per rule number 5, because we already know this is rule 5, so I'm not going to do the partials right now. Okay, so we need to arrange it and make it look like rule number 5, right? So as I told you the process, just focus on the first term, okay? The first term that is associated with dx. So whenever I'm taking dx, I should have a y along with it, okay? I can see there is no other constant to associate it. So now what else is remaining? One more y is remaining. Now check that if I take a y common, then from the other terms which are present over here, can I take a y common? Obviously you cannot take a y common from x cube, so that means you can take a y common from here, right? So if I take the y common, what am I left with? Minus x dy. So I'm left with a minus x dy. So that means over here we have paired these two terms, right, present over here. So obviously now you can understand we have to pair the remaining two terms. So for the remaining two terms, again with dx, I need to have a mandatory y, right? So a y dx. If I take a y dx, I need to keep the constant also inside. So there's a 2. So 2y dx, I'm left with the x square. So x square must be outside. So now if I take x square common from this term, I'm left with a 2x. So plus 2x dy equals 0. Okay. So now you can compare this with the general form and you can directly comment that there is no x present. That means x power 0, y power is 1. So that means your a is 0, b is 1, your m is 1 and your n is minus 1, right? Your n is minus 1. And then again there is no y present, so that means it's a y to the power 0. So your a dash is 2, which is the power of x, b dash is 0, which is the power of y. Your m dash is this coefficient, which is 2, n dash is this coefficient, which is again 2. So you're going to solve the equations. A plus h plus 1 by m equals b plus k plus 1 by n. So if I plug in these values over here, I will be getting a plus 1, that means 0 plus 1 is 0, so 1 plus h by m, that's 1, b is 1, 1 plus 1 is 2 plus k by n, that's minus 1, right? So if I just cross multiply over here, I have minus 1 minus h equals 2 plus k, so that means I am having h plus k equals minus 3, right? Again, I'm going to plug in the next set of equation, which is a dash plus h plus 1 by m dash plus b dash equals b dash plus k plus 1 by n dash, and if I plug in these values over here, so a dash is 2, 2 plus 1, that's 3, so 3 plus h by m dash, that's 2. B dash is 0, 0 plus 1 is 1, plus k by n dash, that's 2, so 2 is getting cancelled, so I have h equals 3 that side, so k minus 2. So if I plug in this value right over here, I'm going to get k minus 2 plus k equals minus 3, so that's 2k equals minus 1, so k equals minus half. Right, so if I plug in this value again back over here, I will be getting h equals k is minus half minus 2, so your h would be minus 5 upon 2. As I told you, we have got fractional value, so that means this question you couldn't have done with any other rule. So your integrating factor would be x to the power h, so x to the power minus 5 by 2 into y to the power k, that means minus half. So basically you have 1 by x to the power 5 by 2, y to the power half, and this is your integrating factor. Now the question, because solving the question is a little elaborate, so I'll not do that right now. So you can multiply this integrating factor with the given question on both sides. You'll understand each of the terms are going to become fractional as you're dividing by fractional powers of x and y. Then again integrate them term by term and get your final answer out of it. So that's going to be an elaborate process. Again, you can do it, tell me the answer in the comment and I will verify it for you. Okay, so these are all the rules of non-exact differential equation and the rules for finding the integrating factor of it, then solving it. Okay, so in the next lecture we are going to do linear and Bernoulli's differential equation and we are going to solve those differential equations. See you in the next lecture. Bye bye.